In this video, we'll be talking about extrema. So we will say f of c is an extrema where it can be either a local maximum if f of c is greater than or equal to f of x near x equals c, or a local minimum if f of c is less than f of x near x equals c. So here we see a maximum occurring because the function value is largest near x equals c, and a minimum occurring here because the evaluation is smallest near x equals c. We will define a critical number c where f prime of c, the derivative of f, is equal to 0 or does not exist. To determine if the critical number gives a maximum or minimum, we will use the first derivative test. If f changes from increasing to decreasing at x equals c, then f of c is a maximum, as pictured here. And if f changes from decreasing to increasing at x equals c, then f of c is a minimum, as pictured here. A critical number c will not always be a minimum or maximum. If f is increasing or decreasing both to the left and right of critical number c, then f of c will be neither a maximum or minimum. In this example, we will go through finding the local extreme values of f of x equals x cubed minus 12x minus 5. So first we want to find the critical numbers for f of x, where we'll go ahead and take the derivative, f prime of x. Using power rule, we will get 3x squared minus 12. And we want to find where this does not exist or is equal to 0. This polynomial exists everywhere, so we will only have solutions when the derivative equals 0. We'll go ahead and solve this by adding 12 to both sides. And then we'll get 3x squared is equal to 12. Divide through by 3, we'll get x squared is equal to 4. And we will get critical numbers at x is equal to plus or minus 2. Now we'll go ahead and check whether f is increasing or decreasing to the left of these values. So I'll go ahead and make a number line. And we'll test values in between. So 0 will be easy to check. We'll go ahead and test -3 as well as +3, and we can get the derivative evaluations, which will tell us if it's increasing or decreasing at those values. So f prime of -3 will be 3 times -3 squared minus 12, which is 27 minus 12 is equal to 15. Since this number is greater than 0, we know that the function f is going to be increasing to the left of x equals -2. We'll go ahead and get f prime of 0, and we will find that this is 3 times 0 squared minus 12, which is just -12, which is less than 0, showing that our function will decrease in between -2 and 2. And we will get f prime of 3, similar to f prime of -3, to be 3 times 3 squared minus 12, which is 15. Again, greater than 0, telling us our function will increase to the right of x equals 2. Now if we look at this critical point, x equals -2, we see that since the function is increasing until x equals -2 and decreasing after, then f of 2 is a local maximum. And since the function is decreasing until critical number x equals 2 and increasing after, we have that my apologies, this should be f of -2, and f of 2 is a local minimum. And those are our answers.